Welcome to ePathshala PG courses on computer science. This course is about web technology and this is the first module. We will see the introduction about the web technology. The learning objectives of this module are: we will know the breadth of the internet and web technologies, and we will also study about the internet protocols and the internet IP addresses, etc. The internet is actually a network of networks with different hardware and software technologies. We know that when two or more systems are connected, host computers are connected, it forms a network, and when two or more networks are connected, they form an internet. And when two or more systems, host systems are connected, we do not have any problem because the systems are compatible with each other. Whereas, when two or more networks are connected, the compatibility issues are there, where there exist different hardware issues and software issues. So, we need to deal with the challenges that exist in the hardware level and in the software level when we connect different kinds of networks. So, these incompatibility issues that can be dealt in a hardware can be overcome with different introduction of different hardware devices like internet networking devices like routers, bridges, switches, repeaters, gateways, etc. And the software issues can be handled by a protocol called a TCP/IP protocol. So, the TCP/IP forms the backbone of the internet to deal with the incompatibility issues that exist in the software level when you combine the different kinds of networks. The name TCP/IP is given by the two important protocols in the two different layers called the transport layer and the internet layer. The TCP protocol, the transport control protocol that comes in the transport layer, and the internet protocol that comes in the network layer. So, now the internet today is based on the internet service providers called as ISPs. The internet service provider is a business or a company that provides individuals and organizations access to the internet, and different internet service providers charges and they provide different kinds of services. So, the host computers has to get connected to the internet service provider in order to get connected to the internet. And when we see the internet network architecture, there are two providers called the network service providers and the internet service providers. So, in the low level, we are the host computers, the end users who need to get connected first to the internet service providers, and the different internet service providers are connected to the network service providers, and they are connected to the high speed backbone network. The internet service providers, they get the bandwidth or they buy the bandwidth from the network service providers and in wholesale, and they provide in retail to the users, and they are also responsible for providing an unique IP addresses to the users. So, the two main functionalities of the internet service providers are to provide the bandwidth to the users and to provide an unique IP address to the users. Through an internet service providers, the host computers can be connected to the internet, and they are connected to the network. Internet service providers are connected to the network service providers, and through network service providers we are actually connected to the internet, the backbone network. There are three main ways we can connect to the internet. One is through a dial-up connection, or we can have a high speed DSL connection, or we can make a wireless connection, that is a Wi-Fi connection. And let us see about the internet protocols. So, in order to, as I told you, in order to deal with the software issues, there exists a common protocol called TCP/IP protocol, and that is the backbone of the network. So, all the systems or host computers that are connected in the internet should conform to this common protocol called TCP/IP protocol. So, the communication protocol suite, the TCP/IP protocol, is actually a packet switched protocol and which does not provide an end-to-end connection. So, every message that has to be communicated in the internet is broken down into small pieces called packets or datagrams, and they are routed to the destination over different paths. So, the two protocols called the TCP protocol and the IP protocol, they are responsible for making this communication possible. The transmission control protocol breaks messages into packets and they numbers the packets in order, and at the destination end it reorders, the TCP protocol reorders the packets and then make it as a message to the destination computer. The internet protocol is responsible for routing the packets to the proper destination. So, now let us see about how this TCP/IP model looks like, and it has become the standard of the internet. So, compared to the OSI model, so in any network, in a network where host systems are connected, if we have the protocol OSI protocol, it is of 7 layers that would make the communication possible. In a TCP/IP model on how an internet works, the 7 layers are summarized into 4 layers or 5 layers. So, in the diagram as shown, figure as shown, we can see that there is a layer called the application layer. So, the 3 layers, the application layer, the presentation layer, the session layer are compressed into one single layer called application layer in the TCP/IP model. The transport layer exists as such in the TCP/IP model, and the network layer in the OSI model is now called the internet layer in the TCP/IP model, and the data link layer and the physical layer in the OSI model is given as the network access layer in the TCP/IP model. So, the 7 layers are given as 4 layers in the TCP/IP model. So, going inside the TCP/IP model, we can see here the application layer, the presentation layer and the session layer. We have a lot of protocols like SMTP protocols, FTP, HTTP, DNS, SNMP, Telnet and so on. These are the application layer protocols. So, the 3 layers combined together called as an application layer in the TCP/IP model. And in the transport layer, we have protocols like TCP and UDP. In the network layer, we have important protocols. The important protocol, that is IP protocol. Along with it, there are 4 more protocols called the ICMP, IGMP, RARP and ARP protocols. And the data link and the physical layers are now called as the network access layer in the TCP/IP model. And we can see the relationship of layers and addresses in TCP/IP. In the transport layer, we call the communication happens through the port address. In the network layer, the communication happens through a logical address or called as an IP address, and in the data link layer, the communication happens via through a physical address. So, we need, for a communication to happen, we need all the 3, the port address, the logical address and the physical address. So, let us see about the application layer. This handles the high level protocols, the issues like representation, encoding and dialog control. In the application layer, we can see that for doing a file transfer, we have protocols like file transfer protocol called as FTP and then an NFS. Then to provide an email service, we have a protocol called SMTP, which is a simple mail transfer protocol. To provide a remote login, we have 2 other protocols called Telnet and RLogin. For giving a network management, we have a protocol called SNMP. For doing name management, we have a protocol called domain name systems, and they are all used by the router. And some of the applications that run in the application layers uses TCP. In the transport layer, we have seen that there are 2 protocols called TCP protocol and UDP protocol. In the application layer, there are several services, several protocols run for providing different services. So, some of the services uses a TCP protocol, say for example, a file transfer protocol, a simple mail transport protocol, a Telnet and a hypertext transfer protocol. All these are relying on a TCP protocol in the transport layer. A file transfer protocol provides the ability to upload and download files between hosts on the network, and a simple mail transport protocol provides the ability to send mail between users on the network, and a Telnet provides the ability to log in to a remote host and administer the machine, and a hypertext transfer protocol provides the ability to supply web pages between a browser and a server. And some of the applications uses a UDP protocol. Say for example, we have a trivial file transfer protocol that provides a simplex file transfer for network booting of devices. A network file system provides the ability for sharing directories between hosts on the network. A simple network management protocol provides the ability to supply network related services on the network, and then a domain name service, a DNS, provides mapping between the domain name and IP addresses. And what are the functionalities of a transport layer? So, the 5 basic services of a transport layer are to segment the upper layer application data and to establish an end-to-end communication. So, the messages that are sent from the application layer are split into segments, and then they are sent from the source to the destination, and it also ensures a data reliability, and it also provides a flow control. The 2 protocols in the transport layer are the transmission control protocol called the TCP, which is connection oriented, and the user datagram protocol called UDP, which is a connectionless protocol. The transmission control protocol provides the application programs access to the network using a reliable connection oriented transport layer service. So, TCP sends and receives data reliably using sequence numbers and acknowledgements. So, here every message that is split into segments or assigned a sequence number, and the data stream is handed over to a TCP. Handed over to a TCP, it is actually called as an unstructured stream. The TCP divides this data stream into segments for transmission to remote network. So, the message that is coming from the application layer is actually split into segments, and each segment is assigned a segment number or a sequence number, and they are transmitted from the source to the destination. When it reaches the destination, this TCP protocol will again reorder the packets or reorder the segments, and then finds out which are the segments that are missing out or lost, and then send an acknowledgement to receive the other packets or other segments that are actually missed out. So, the TCP actually provides a reliable connection oriented service. So, IP is actually a connectionless best effort delivery service, whereas TCP is a connection oriented reliable service. To make IP as a reliable service, we need a TCP on above an IP protocol. So, TCP is what providing a connection oriented transport layer service. When we see about the user datagram protocol, it is actually an unreliable connectionless service. This actually transfers data without establishing any session. So, no connection is established between the source and the destination, and it is actually used for services that have an inbuilt reliability. So, we assume that the services should have an inbuilt reliability, and it is mainly used, this UDP protocol is used for critical applications, and that also require a high speed. Say for example, if you want to stream data, then we need an UDP protocol. So, this UDP will take care of, we do not worry about whether the packets or segments are lost. So, no connection is established between the host and the destination, and no acknowledgement or sent for any of the packets that is lost. So, it does not order the packets. So, you may lose or duplicate a packet, but it runs faster than TCP due to the less overheads, and it is mainly useful for many very critical applications. And coming to the internet layer, this actually would do a routing. This internet layer is for routing the packets to the destination. So, it is actually a best path determination and packet switching protocol, and in the internet layer we can see that the main protocol is the internet protocol, and added with this internet protocol we have other protocols running in the layer called internet control message protocol, the ICMP, the address resolution protocol called ARP, and the reverse address resolution protocol called RARP. So, this internet protocol provides a best effort or connectionless unreliable delivery service. So, IP does not worry about the reliability of the service, the reliability is taken care by the TCP protocol. So, here the IP will also not do any error checking or tracking, it does not even do an CRC checking, but it routes the packets, and the packets may be taken through different routes. So, each packet may take a different route, and then it can reach the destination. The ordering of the packets is going to be done by the TCP, the transport layer protocol, and then it is going to given to the application layer. So, this IP protocol, the internet protocol, transmits blocks of data called datagrams, each of which is transported separately. Every packet can take a different path, it is just routing. IP is just routing, it is routed through different paths, and it is mainly responsible for IP addressing. And as told, datagrams may travel along different routes and may arrive out of sequence or duplicated. And reliability is actually provided, or the responsibility of ordering all the packets and to provide reliability of the service is done by the transport layer protocol called the TCP. Now, you can see the diagram. IP, how it works as a routed protocol. So, let us take the application as an email application which is running in the application layer. So, the email data is actually segmented in the transport layer, and they are added with a sequence number, and in the internet layer it is the data is added with the network header where the IP address is added, and in the data link layer or the network access layer, along with the network header, the frame header is added, and it is routed through different paths. Now, let us look about what is an IP address. So, without an IP address, a packet cannot be routed. So, in order to identify the address of the source or the destination from where it has to go or to where it has to move, we need an address called an IP address. This IP address is not the physical address of the host computer, it is actually the logical address of the host computer. The IP address is initially assigned by the internet service provider to the host computer, whoever wants to access the internet. So, initially when we take a host computer, they are provided with a physical address. Normally it is available in the network interface card. And this, when you take an internet or a network, the computers cannot connect with the physical address because different addressing mechanisms may be there. So, we need to have a common, this TCP IP protocol, commonly it works on a common protocol called TCP IP protocol, where this IP protocol needs an address, a logical address called IP address. So, this IP address is a 32-bit sequence of ones and zeros, and in order to make it easier to use, it is actually written as 4 decimal numbers separated by periods. So, the 32 bits is written as 4 different octets. So, now here you can see that the first binary, every 8 bits forms a decimal number. So, 32 bits, so every 8 bits of 32 bits forms a decimal number. So, it is going to be of 4 decimal numbers, every IP address is going to be of 4 decimal numbers. So, this IP address has 2 parts, a network and then a host address. And when you look into the IP addresses, they are divided into different classes called A, B, C. We can define that as a large network, medium network or a small network. And there are 2 other classes called class D and class E. Class D addresses was created to enable multicasting, and IETF reserves this class E addresses for its own research. So, let us look out how this IP addresses are given in different classes. In class A, we can see that the first out of 32 bits, the first 8 bits are network address and the remaining 24 bits are host addresses. In class B address, the first 16 bits are network addresses and the rest of the 16 bits are host addresses. Class C, we can see the first 24 bits are network and then the last 8 bits is a host address, which means that a class A is for a large network and a class B is for a medium network and a class C address is used for a small network. Large network means that you can see that you can have n number of hosts. In a class A, the number of hosts you can connect to the network can be more. So, it can be a very large network, but the network addresses are only of 8 bits. Class B, it is going to be a medium network and class C addresses are used for a small network. And class D is for multicasting, as I told, and class E is reserved for research, for its own research. So, now we can see that each of this classes, in order to identify each of the IP address to which class it belongs, the higher order bits has got a 0 in class A, in class B it has got a 1 0, the first 2 bits are of 1 0, in class C the first 3 bits are of will be of 1 1 0, it starts with 1 1 0, class D it starts with 1 1 0. So, the address ranges, the first octet, if we can see that whether it is a class A, class B, class C or class D. So, if the IP addresses is starting from 0 to 127, the first octet address range is of from 0 to 127, then it is a class A address. If it is from 128 to 191, then it is of class B. If it is of 192 to 223, it is a class C address, and it is of 224 to 239, it is a class D address. So, this we have already seen how many bits you will have in the network address. Class A, it is of 8 bits for the network, class B it is of 16 bits 24, class C is 24 and class D is 28 bits. And the number of networks you can have in class A is 126, whereas the number of hosts per network is, you can see that 16, 777, 216. And class B it is for medium networks, and we can see that how many networks you can form and how many hosts you can get connected to each network. Now, these are all reserved IP addresses. So, certain IP addresses are reserved and cannot be assigned to devices on a network. So, if an IP address has got all binary zeros in all the host bit positions, then it is reserved for the network address. And an IP address that has a binary ones in all host bit position is reserved for the broadcast address. So, now we can see that the network address where all the host bits are assigned all zeros. So, here 176.10.0.0 and then it is assigned as a network address, and all the host bits, when it is assigned as ones, they are for broadcasting. So, here we can see an example 176.10. The host bits, the 16 bits, the host bits or 255.255. So, they are actually a broadcast address. And now, along with this IP protocol, I told that there are 4 protocols that are running along with IP protocol called the Internet Control Message Protocol. One is an Internet ICMP protocol. This is a mechanism used by host and routers to send notification and datagram problems back to the sender. So, as such, IP does not worry about whether our packet reaches the destination. IP just routes the packets. So, supposing if there is any problem when the packet could not be delivered to the destination, an error message can be sent to the source, and it is sent only to the source and not to the nearby routers. So, the sole function of this protocol is to report problems and not to correct them. So, some of the error messages, the protocol messages that can be sent by this protocol are a destination unreachable, source quench, redirect and time exceeded. So, when a router understands or identifies that the destination could not be reached when some host get into an error or some host could not be connected in the internet or in trouble. So, in that case the router sends a destination unreachable, this packet could not be reached to the destination. So, the router sends a destination unreachable message to the source. Source quench message would be sent by a router when the router is not capable of handling all the datagrams that is sent by different sources. So, the capacity of the router is not, it is slow that all the packets could not be handled at a time by this router. So, it started dropping the packets, but it cannot as such drop the packets, it has to report to the source that do not send me the packet. So, it sends a source quench message to the source saying that do not send me the packets, I am not able to take away the packets. And a redirect message can be sent when it takes a wrong path. So, when a packet is sent through a path and if there exists no path to reach to the destination from there, then the router automatically sends a redirect, so that the packet could be redirected through a different path. And there is a message called time exceeded message that could be sent by this protocol. Every IP packet is assigned a parameter called a time to live. So, understanding or assuming that how many routers it would cross through, this source would set, the IP protocol in the source would set a time to live for the packet, so that the packet would live for that period of time and it would die. After that it would not reach the destination. So, supposing if the packet, the main reason is that the packet should not go for a long it should not here and there go in the network. So, it assigns a time to live parameter, the IP packet has a time to live parameter. So, when a packet is not able to reach the destination within the time period, it would be dropped. So, when the time exceeded and the packet is not able to reach the destination, this message would be sent back to the source. And there is a protocol called ICMP, it is an Internet Group Message Protocol. This allows for multicast to operate on an internet. So, multicast is actually a one-to-many communication, so that a message can be sent simultaneously to a group of users. And we saw that there is a special type of class D IP addresses. It all starts with 1110 and they are reserved as multicast addresses. There is another protocol called an address resolution protocol working in the internet layer. This is used to translate the 32-bit IP addresses to 48-bit Ethernet addresses. We know that the IP address, the logical address would be of 32 bits, and every communication to take place, the system has to have an IP address, and the packets are all addressed with an IP address. Now, but the systems are identified by a physical address. Every physical machine has got a physical address which is of 48 bits. So, there should be a mapping from this 32 bits to 48 bits. So, this ARP, the address resolution protocol, handles this. It does a mapping from 32 bit to 48 bit Ethernet addresses. There are 3 methods by which it can do a mapping. Either it can make a table lookup, this is a very old method, or it can make a closed form computation. So, you have a table where there is a mapping between an IP address and the physical address, but this table has to be dynamically updated for every machines that are added to the network. Closed form computation method would be used where From the 32-bit address, we do some mathematical computation and we will try to get the 48-bit physical address. This is also not useful. So, we commonly use the third method called the message exchange. So, what will happen in the message exchange? A host physical address is determined by broadcasting its IP address to all machines. So, a mission will do is it will just send its IP address. When a packet reaches the network, the destination network, it has to identify to which host computer the packet has to be sent. So, it just broadcasts the message to all the machines. The machine with the matching IP address sends its hardware address to the machine originating broadcast. So, now it identifies that what would be the physical address for this 32-bit IP address. So, this ARP protocol provides using a message exchange. So, just it will give the IP address and tries to find out what is going to be the physical address. So, the one which has the matching IP address would send its physical address, from which we can understand which can be the destination host. And it is a reverse address resolution protocol. It is an RARP protocol. This works in the reverse of an ARP protocol. This reverse address resolution protocol is used to get the 32 bits source IP address knowing the 48 bits hardware address. So, some machines would not have the IP address. Say for example, this all happens when you have a diskless workstation. Normally, the address would be stored in its disk. There can be workstations connected to the network which will not have any disk. So, it requires to find its IP address at the time of the boot up. So, the one that is the central server alone responds and all other machines would not respond, because it alone has its address for its physical address, it alone has the IP address. And even this RARP protocol works when a new computer joins the network, it will not have its IP address. Again, its IP address can be assigned by a central server. So, by using this protocol, it tries to find out what is the IP address. And there is a layer called the network access layer. The network access layer is the physical layer, the physical and the data link layer, which is going to be of the different protocols or Ethernet, and there are a lot of it. So, the underlying protocols that works in the data link or the physical layer or Ethernet, token ring, and FTDI, frame relay, point to point protocol, and ATM. So, let us come to the summary of this presentation, this module 1. What we have seen in this module is the internet and its basic concepts, and the backbone of the internet, which is the TCP/IP protocol, and we have explored about the protocols in the TCP/IP model. Thank you.